I'm going to find the area under the curve of 1 over 3x plus 2 between 0 and 2. This function is discontinuous at x equals negative 2/3. What you should do is just check to see if possibly the denominator is 0 at either of your limits of integration or somewhere in between these two numbers. But it's not. It's undefined at negative 2/3, and so this should be good. We should be able to find this function's area between 0 and 2. We should be able to find this area here under the curve, y equals 3x plus 2 on the denominator, 1 over that. When x is 0, y is a half, and then when x is 2, it turns out that y is an eighth. And so we need to find this area here, and we're going to do it by doing a U substitution. Now usually with U substitution, it stands out at what to let U equal because there's some defined function that's raised to a power or in the exponent of an e. Here it is, just the denominator, really. We're going to let U be the entire denominator. We're going to let U equal 3x plus 2. When you do that, take the derivative immediately and you get du is 3dx. We have to substitute for dx as well, and so we divide by 3 on both sides, and we get 1/3 du is equal to dx. And so now we can do our substitution. We have 1 over 3x plus 2. That becomes 1 over u. And then we have dx, that becomes 1 over 3 du. And so we integrate that, which is much simpler to do. The goal is to get a simpler integral, and we can do this one. We pull the 1/3 out, focus on 1 over u, and the antiderivative of 1 over u is the natural log of u. Be careful, that's the one where you can't use the power rule in reverse. You can't bring the -1 up as the exponent and use the power rule in reverse. Doesn't work out, because if you do, just think what happens. You're supposed to add 1 to the exponent and divide by the same thing, but that'll be dividing by 0. So it doesn't work. You just have to remember that the antiderivative of 1 over u is the ln of u. Now let's change back into x. Replace the u with 3x plus 2. And what we're doing here is announcing that we're about to plug a 2 in, we're about to plug a 0 in, we're about to subtract. We're about to finish off the fundamental theorem of calculus. So we plug a 2 in, replace the x, plug a 0 in to replace the x. And what we're getting is the natural log of 8, right, 6 plus 2, and the natural log of 2. Then you look in the answer and you're discouraged because you don't see exactly this answer. So sometimes what happens at the end of these kinds of problems is you have to combine the logs together using properties of logs. The log of a minus the log of b is going to be combined into a single log, the log of a over b. And so the log of 8 minus the log of 2 will become the log of 8 over 2. No, natural log, I mean. And then that 8 over 2 cancels to be the natural log of 4. So our answer to this question is 1/3 of the natural log of 4. Don't forget about the 1/3 from the U substitution. Now, had this been a perfect cube, then it's possible that we could have gone a step further and brought that up as the exponent on that, because the property of logs, when you have some product, some number multiplied by a log, you can bring that up and become the exponent on the inside. It's not making it any better to write this as the natural log of the cube root of 4. Now, if it was a perfect cube, then that would be great to do. but it's not. And so this is the most simplified form of it. We'll just go with this. Take the natural log of 4 essentially and divide it by 3. Okay? All right, great.